Let's trace through this demo program called Aliasing demo. We have flick, and flick is an object variable. The computer assigns it an object reference to a location in the memory of the computer where there's enough room to store a bug object. And perhaps the memory address is A32. We have no way of knowing that as a programmer, but just know that some memory address, such as A32, is stored in the object variable named flick. And more specifically, at that memory location A32, there is a color property, which default bugs are red, according to the API. And there's a default direction, which is north, also known as the number 0. There's a default location, which is 0, 0. Now within the location object, because this is really an object within an object if you want to consider it that way, the row is 0 and the column is 0. So it's really a location object, just like it's a color object that stores the idea red. And it's really probably a direction object that stores the direction of 0. It's not even an int, it's probably a direction object. Okay, and then we have ADA. Well, because of the way that Java works, there's some memory location in the stack of in the heap of the computer, a special part of the memory called the heap, where we have enough room for another bug object. And that bug object is green, and direction is 90, as you see there. And the row and column are 1 and 2. In other words, the location object within that bug is 1, 2. So that bug's object variable name is ADA, and really all that an object variable does is it stores a memory address, also known as a reference. And B52 is my example for what possibly would be stored there. So ADA points to that chunk of memory, and flick, you could say, points to this chunk of memory. Next line of code, flick.getLocation. Well, let's look up flick. Flick is a memory address A32, which takes us to this chunk of memory, and the getLocation method would pull out the location, which is 0, 0. And that's why that's the answer to what prints out for that line of code, system out print 0, 0. The line of code flick equals ADA, where it's an assignment statement that works from right to left. So that which is stored at ADA, B52, is overwriting what used to be stored at flick. So cross that A32 out, carefully record that B52 is stored there now, and that's what that is. That's an example of what we call aliasing, which is the whole purpose of this demo program, to illustrate and teach what aliasing does. So the next line of code, system out print flick location, flick.getLocation. Flick is B52, which no longer points to that chunk of memory, but rather likewise points over here like the ADA object variable does. So the location at B52 is 1, 2, and that's why we have that written there as sort of the output of that line of code. The line of code flick equals null is telling the computer to put the memory address 0 into flick. So cross out the B52 and put a 0 there. This next line of code, I had to carefully comment it out because it would cause an error if you tried to execute this program or even compile it. Well, no, it's a runtime error. So if you tried to execute this line of code, it would crash when it runs. Flick.getLocation. Because flick is currently 0, it is not pointing to or tied in any way to either of these objects in the memory of the computer. So flick is really just a variable, an object variable that is nothing. It points to nothing. So that causes what we call a null exception error. You cannot call a public method if something is simply declared as a bug but not instantiated with actual an object in the memory of the computer at that point in the program. In other words, setting an object variable equal to null is sort of the opposite of instantiating it with the word new. Okay, next line of code. System out print ada.getLocation. Well, ada still exists. She is the memory address B52 which points over here to this chunk of memory. And looking for her location, we see it's 1, 2, and that's why I wrote that there. Next line of code, flick equals new bug. Well, because of that, the computer gives birth to flick. So at this moment, notice that neither of my object variables are making use of A32. So that chunk of memory would have been reclaimed by the operating system of the computer device. And therefore, that chunk of memory is free again. It's highly unlikely, possible, I'm not sure, but A32 might now be used as the memory address for this new rebirth of flick because of this default constructor call statement. It could be A32, but to make this more interesting, I'm just going to pretend that the memory address is D4. I just made some hexadecimal number up, D4. And the default constructor, again, makes the color of this bug flick this time around. The default color, I believe, is red. The direction is 0 north, and the location is 0, 0 for flick. And flick is no longer stores the number 0, but flick stores the memory address D4. And therefore, you can think of flick as pointing to this chunk of memory. So we analyze this line of code. System out print flick.getLocation. Well, that's simply 0, 0. We just saw that. And this line of code would be an error if you tried to execute it or even compile it. You can't directly access a private property of a class from a client program like we are executing right now. So that's an error message. Flick.setLocation, add.getLocation. Well, working from inside the parentheses out, add.getLocation tells us to go to ADA, which is B52, and therefore follow this arrow. The location of ADA is 1, 2. That's nice. So really, we have a location object that was just returned by the getLocation method. So that location object, which is 1, 2, is being sent as a parameter to the setLocation modifier method of the bug class. If you look it up, the bug class, the setLocation method in the bug class, does accept a location parameter. And 1, 2, therefore, is being used to overwrite flick's location. Flick is currently D4. Dereferencing that D4 takes us to this chunk of memory. So that 0, 0 location object is overwritten with a location object that stores 1, 2 in its row and column properties. So the next line of code, system out print flick.getLocation, prints out flick's location, which is this location right here, 1, 2.